Assalamualaikum students. Today we'll be learning about the discriminant and the nature of the roots of quadratic equation, right? So in the quadratic formula, the quantity b squared minus 4ac under the square root sign is called the discriminant. So we can write the quadratic formula, that is x is equal to minus b plus minus whole square root of b square minus 4ac over 2a, right? In this formula, you can see that the expression inside the square root, right? So this expression, this one, this b square minus 4 is known as a discriminant. Got it? And it's represented by delta. And is used as, so delta it will be equal to b square minus 4ac. And obviously b, a, and c are the coefficients of the quadratic equation, right? So there are three types of roots. If the del is greater than 0, then obviously this thing will be positive, and positive square root will give you two values, two distinct values. So that's why in this case, there are two distinct roots of the quadratic equation. One with the positive sign, this one, and one with the negative sign. Got it? Okay, and if the del is equal to 0, means the thing inside this square root becomes 0, so which means there will be only one answer. So it has only one solution. Or we can say it is repeated or double root. Got it? Or equal roots. And the third case will be when this del is less than 0. So in this case, it says negative number inside the square root sign. And obviously, this will give you a non-real number, right? Because it's a negative number inside the square root. So the answer will not be a real number. So in this case, the roots will be not real roots. Got it? Okay. Now we'll be solving questions to understand this concept. So in exercise, we have exercise 2b. In this exercise, question number 1 is consider the quadratic equation this. Find the discriminant. So the quadratic equation we have is x squared minus 7x plus 9 equal to 0. And if we compare this quadratic equation with the general form of quadratic equation, which is ax squared plus bx plus c equals 0, we can conclude that a equals 1, b equals negative 7, and c equals plus 9, right? So I'm writing here a equals 1, b equals negative 7, and c equals 9. Got it? So what is the discriminant? And if you see that the discriminant is delta equals b squared minus 4ac. So I'm writing the discriminant equals b squared minus 4 times ac. Now inserting the values, b is negative 7, this becomes negative 7 square minus 4 times a is 1, and then c is 9, right? So negative number, the square of negative number is always positive. So negative 7 square is plus 49, minus 4 into 9 is 36. And it will give us 13. And obviously it is greater than 0. So this is actually this type, when the del is greater than 0 or positive. So in this case, we have two distinct real roots, right? So we hence state the nature of the roots of the equation. So we can say that two distinct real roots, as discriminant is greater than 0, right? Okay, check your answer in part B by solving the equation. Okay, we'll be solving this equation by using the quadratic formula, that is x is equal to minus b plus minus b square minus 4ac over 2a, right? Now inserting the values here, minus b means minus 7. Then plus minus 7 square minus 4 times 1 into 9. Whole over 2a, 2 into 1, right? So minus into minus plus 7. And what we are left with is discriminant. So discriminant was 13. So 13 square root over 2. So 1 with a positive square root 13, and second root will be with the negative square root 13, right? Like this. So this will give us two different answers, obviously. I'm using my calculator to simplify this. So the first one is 7 plus square root 13 and divide by 2. So the first answer is this, 5.30. Obviously a real number. Second will be the negative square root 13. So we get 1.70 in three significant figures, right? So you can see there are two distinct answers and they are, both are real. So distinct real roots. And we have proved that. Okay, now moving to the next question. Question number 3 of the same exercise. It says, without using the discriminant, explain why the equation this is a quadratic equation given, has no real roots. So I'm going to solve it. X square plus 5 equal to 0. Shifting this to the other side, it will be x square equal to negative 5, right? Now, if I take square root of both sides, I'll have this. And we know that the square root of negative number is not real number. So that's why we can say that no real roots, right? Now in part B, we have to check that del is less than 0 for this equation. Okay, let's see. I'm writing the equation again, x square plus, there isn't any term for this x, so I'm just writing it as 0x, then plus 5 equal to 0. Now I'm comparing this with the general form of the quadratic equation. I get a equals 1, b equals 0, right? And c equals 5, right? So writing here a equals 1, b equals 0, and c equals 5. Now finding the discriminant, which is b square minus 4ac, right? So what is b here? Obviously 0 square minus 4 times a, 1, and 5 is c. So we get 0 minus 20, and it is minus 20, which is obviously a negative number, right? So the del is less than 0, right? Which obviously states that there is two roots, but they are not real. So this is actually the third case when we have no real roots, right? Okay, now moving on. Question number 4. Using the discriminant, only state the nature of the solution of obviously these quadratic equations, right? So I'm going to solve part C. In part C, the quadratic equation is 3x squared plus 2x minus 1 equal to 0. Comparing with the general form of quadratic equation, we get the values of A, B, and C. A is 3, right? And B is 2, and C is negative 1, right? So I'm writing here A equals 3, B equals 2, and C equals negative 1. Now, finding the discriminant, which is delta equal to B square minus 4 times AC. B is, 2 square minus 4 times 3 times negative 1. So we get 4 minus into minus plus, 4 3 are 12. So it is 16, right? And obviously it is greater than 0. So in this case, when the discriminant is greater than 0, we say two distinct real roots, right? Okay, another part, I'm going to solve it. Yeah, it's F part. 16x squared minus 8x plus 1 equals 0. Comparing with the general form of the quadratic equation, we get a equals 16, b equals -8, and c equals 1, right? Okay, finding the discriminant, which is b square minus 4 times ac. B square is minus 8 whole square, and minus 4 times a is 16 times 1, right? So it is plus 64 and minus 64. So it is 0. So when the discriminant becomes 0, it means we have real roots, but they are equal roots, right? So like in the case, you can see this third case, when, second case, when the discriminant equals 0, it means it has only one solution, right? So, which we call a repeated or double root. So only one real solution, right? Okay, next question. Using the discriminant only determine which of the following quadratic equation have rational roots and which can be found by factorization. Rational roots. Okay. Let's see. In part A, we have, in A part, I have 6x squared minus 5x plus minus 6 equals 0. Comparing with the general quadratic equation, we get A equals 6, B equals -5, right? And C equals -6. Now finding the discriminant, B squared minus 4AC. What is B? Obviously -5, and -5 squared minus 4 times 6 into -6. So we get 25 minus into minus plus, 4 6 are 6 6 are 36, and into 4 is 144, right? So it will be 169. And 169 is a perfect square. You can see. So, and in the quadratic formula, we know that the quadratic formula is x is equal to minus b plus minus b square minus 4ac, or we can also write it as delta over 2a. So if the number inside the square root or this delta is a perfect square, it means its square root is possible, and it gives you the square root gives you a whole number, right? So when we have the whole number, it means we can have two different answers, obviously, and both should be rational numbers. Got it? So whenever the discriminant is a perfect square, we have the solution, like the solution to two distinct values or real numbers, both should be rational numbers. Got it? And we can confirm it as well. Like x is equal to minus b means minus 5 plus minus, it's 169, yeah, over 2 times a is 6. So it is 5 plus minus 13, because square root of 169 is 13, over 12. So we have two different roots, one with a positive sign and one with a negative sign, right? So we get 18 over 12, and this is obviously minus 8 over 12. So 18 over 12 gives you 6 3s are and 6 2s are. Similarly, 4 2s are and 4 3s are 12. So we get 3 over 2 and minus 2 over 3. and they are rational numbers, obviously, right? So whenever we have the discriminant is a perfect square, that means the roots will be rational. Got it? That means part A, the equation given in part A has rational roots, right? So it has rational roots. Okay. Now moving to the next part, that is part B, right? So in part B, I have 2x squared minus 7x minus 5. Comparing it with general form of the quadratic equation, I get A equals 2, B equals -7, and C equals -5, right? Now finding the discriminant, which is B squared minus 4AC. B is -7. So -7 squared minus 4 times A is 2, and C is -5. So we get 49 minus into minus plus, 4 2s are 8, 4s are 40, right? So it is 89. And obviously it's not a perfect square. So when we have a number that is not perfect square, so it means the roots will be irrational, right? And they cannot be solved by factorization. So we can say the roots are not rational. Hence, cannot be solved by factorization. Right? Okay. Moving to the next question. For each of the following quadratic equations, find the discriminant in simplest forms, hence find the values of m for which the equation has a repeated root, 2 distinct real roots, or no real roots. Like in part A, I have the equation x squared plus 4x plus m equal to 0. Comparing with general form of the quadratic equation, we get a equals 1, b equals 4, and c equals m, right? This is 1. So a equals 1, b equals 4, and c equals m. So in part 1, the first case, when we have the repeated root, right? So in the first case, repeated root means the discriminant should be equal to 0, right? So, okay, now I'm putting the value discriminant is b squared minus 4ac. Got it? And it should be equal to 0. So what is b? B is 4 squared minus 4 times 1 into m. So 16 minus 4m equals 0. And shifting this 16 to the other side becomes -4m is equal to -16. Minus into minus will be cancelled. Or you multiply with -1 with the both sides. So you get this 4m equal to 16. So m will be equal to 16 over 4, which is equal to 4. So for this value m, the roots will be repeated, right? Okay, second part. 2 distinct real roots. In this case, the discriminant must be greater than 0. And we have already found that the discriminant is 16. Yeah, this one. This is the discriminant we have found. 16 minus 4m in this case. So 16 minus 4m should be greater than 0. Shifting this 4m to the other side, it will be 16 greater than 4m, right? Now dividing both sides of 4. So 16 over 4 greater than m. And 4 greater than m, or we can also say that m is less than 4, right? Okay, third part. In third part, it says no real roots. No real roots means the discriminant must be less than 0. And discriminant is 16 minus 4m for part A. So 16 minus 4m less than 0. Shifting this negative 4m to the other side will be 16 less than 4m. Now dividing both sides by 4. So 16 over 4 less than m. Or 4 less than m, or we can also say that m is greater than 4. So these are the conditions for m. If the discriminant is equal to 0, then m must be equal to 4. And second case, when the two distinct roots, that m should be less than 4. And when there is no real root, so in this case, m should be greater than 4, right? And these parts are very similar to it, so you can solve these by yourself, right? I think we should solve another part, that is part C, right? Okay, in part C, the equation is mx squared minus 3x plus 1 equal to 0. What is A? A is m, B is negative 3, and C is 1, right? If I compare with the general form of the quadratic equation. So finding the discriminant, find discriminant first. So del equal to b square minus 4ac. B square is minus 3 whole square minus 4 times m into c. C is 1. So we get 9 minus 4m. So this is actually the discriminant. Okay, in part 1, when the roots are repeated, so it means the discriminant must be equal to 0, or 9 minus 4m equal to 0. That's how we have an equation. We can find the value of m. So 9 is equal to 4m, and divide both sides by 4. So 4 over 9 will be equal to m. So we get m is equal to 9 over 4, which will be 2.25. Right? Okay, next part. Two distinct real roots. In this case, we have discriminant greater than 0. Discriminant was 9 minus 4m. Shifting this 4m to the other side, it will be 9 greater than 4m. Dividing both sides by 4, so 9 over 4 greater than m, right? So it will be obviously 2.25. Or m is less than 2.25, or we can also write as m is less than 2 whole 1 by 4, right? Third case. No real roots means discriminant should be less than 0. So 9 minus 4m less than 0. It will be 9 less than 4m. Dividing both sides by 4. So 9 over 4 less than m. Or it will be 2 whole 1 by 4 less than m. Or we can also say that m is greater than 2 whole 1 by 4. Right? Okay, practice these questions and hope you understand the working we have done of this exercise. If you like the video, kindly subscribe to my YouTube channel. Okay, take care. Allah Hafiz.